Welcome to Math 119, Chapter 1.6, where we talk about solving one variable equation. So these are going to be these linear equations. So you'll notice that in the properties of equality, if you add things to one side of the equal sign, you also need to add it to the other side. So you'll notice that we're adding plus c to one side. So in order to keep it balanced, you have to add something of the same degree to the other side. Same thing if you are multiplying, if you're trying to multiply something out, what you do to one side, you also have to do to the other side. This happens so that we make sure that everything is nice and balanced throughout our equation. So let's take a look at example 1. So solving equations or linear equations. So see if you can pause the video and try to get started on something like this. Now, the first logical step is that we see these parentheses and we want to get rid of it through distribution. So we can go ahead and distribute that 3 throughout on one side. And again, that -2 throughout the other. So we have 3 times x minus 6 plus 7x on one side is equal to 1 minus 2x plus, or maybe even a minus. If you're multiplying -2 times 1/2, the whole number is really over 1. So we're multiplying across with these fractions. So numerator to numerator, denominator to denominator. So you're looking at -2 over 2 or just -1. So from there, now we can combine like terms. So the first thing we wanted to do was to distribute. Now we're looking at combining like terms. So your like terms, we have 3x and 7x. We also have 1 and a -1. So combining these on each side, we're left with 10x minus 6 is equal to -2x. Now, the goal when we're talking about solving linear equations is to get x or your variable alone. So to isolate it. So you'll notice that we have 10x and a -2x. We want to bring these two x's together in order to combine. So let's go ahead and bring x's together. So you'll notice that you have a positive 10x. So we can go ahead and subtract a -10x to the other side. In doing so, we can kind of just cancel those values out, and you're left with a -12x. Now you could, if you wanted to, bring 2 to the other side or 2x to the other side. It's just you're requiring one additional step. And if we want to be nice and efficient, we should be able to bring things to the other side. Now, the last thing we want to do is to get x alone. So right now, x has a coefficient of -12. So to get that -12 away, if it's being multiplied by x, the opposite of multiplication is division. So we're going to go ahead and divide by -12. So then you're left with x is equal to -6 divided by -12 to be positive 1/2. So your final answer should be x is equal to 1/2. Now, if that's all you needed, that's awesome. You can either move on to the remainder of the problems. I would recommend taking a look at the one down below for some helpful tips when it comes to solving with some fractions. So let's do it again. So you'll notice that again, you have a pair of parentheses. So let's go ahead and distribute in. So you get 2x minus 7 is equal to 3x minus 6. So at this point, right, we have things over on the other side of the equal sign. So let's go ahead and combine your like terms. So bringing your x values together and bringing your constants together. Now we want to be smart about where we are bringing your x values, because in the future, we want to make sure that your x's, they kind of stay positive, because what if we have to factor in the future? it's harder to factor with negative leading coefficients. So looking at 2 and 3, which are both positive, right? Well, which one is bigger? Well, 3 being the bigger one, we want to keep its position. So let's go ahead and subtract the 2x to the other side, which means we're going to force the 6 to the other side through adding. So notice that we're just doing the opposite sign. So a negative and then a positive. This one's a positive, so it's now negative. So what we have now, we cancel out those 2x's and the 6's. So then we get to just combine your like terms. So -7 plus 6 is a -1 is equal to 3 minus 2 for just x. So x is equal to -1. Now, when we go to solve, we can just plug these values back in. And if we did it correctly, both sides of the equation will come out to be the exact same solution. So we can go ahead and do that to just check and verify. So if we know that x is equal to -1, when we put it back in, we have 2 times -1 minus 7 is equal to 3 times -1 minus 2. So you get -2 minus 7, which is a -9, is equal to 3 times a -3, which is also equal to -9. So on any sort of test, if you come out with any sort of value for your x or for your variable, just by plugging it back in, you can determine is it correct or not. So if it somehow got unbalanced, you'll notice that it won't come out to be correct. Or if we have something called infinitely many solutions or no solutions. So values that look like they could be true or things that kind of go wrong. So to kind of extend that, let's take a look at this next one. So 5x plus 12 is equal to 5 times x plus 3 minus 3. So again, see if you can pause the video and try this one out on your own. First thing, let's go ahead and distribute that 5. And then go ahead and combine your like terms. Now you'll notice here that you have the same exact values that you do on one side. So even if you were to subtract this 5x to the other side, and maybe you decided to subtract your 12 to the other side, you'll end up canceling everything out. In which case you'll end up with something that just says 0 is equal to 0. So while this is a true statement, this is actually a very peculiar one. This one is called infinitely many solutions. Now it's called infinitely many solutions because these two equations or these two expressions are actually lines themselves. These happen to be lines that are one on top of another. So let's say we have this one in blue. So you have one right here. And then another, let's say this one is in pink. So right on top. And so the reason why we call this infinitely many solutions is that no matter where we are on your lines, we are provided with values that work when we go to enter it in. So no matter what x value we pick, we are always going to be equal to the other side. So these are actually going to be the same exact line. Now, the other ones that we've been working with so far, where x is equal to 1/2 and x is equal to -1, these are called unique solutions. A unique solution occurs when we have two lines that overlap, two lines that intersect. So perhaps they intersect, let's say, down here. So that's one, and this one's another. Let's see, -1, -9. So something like this. So let's say this is one and that's another, right? So they're really intersecting at -1 and -9. So unique solutions are two intersecting lines. We also have one where we have no solution. Now we don't have one listed here for an example, but other than intersecting lines and the same exact lines, what other lines are possible? Well, the other variation is a no solution. No solution is when you have two parallel lines. Now it's called no solutions because parallel lines will never intersect. And they are not the same line, so they will not have any solutions in common. So we have two parallel lines that will never intersect and meet at some point, and they are not the same line on top of each other to give lots and lots of solutions. So your last variation is no solution. Now what that would look like is that one side would cancel out, so perhaps you got 0 on one side, and the other side is probably perhaps 5 or 6 or negative, I don't know, -1/2, right? Well, 0 can only equal itself. So if you come up with a nonsensical answer, that just means we have a no solution. So now let's take a look at this variation where you have some fractions and you notice that your variable is in the numerator. So just like we did in chapter 1.4, right, we can't just add these fractions together. So instead, we need to find an LCD, a least common denominator. Now, if you don't know what that is, please go back and watch 1.4, where we talk all about having to find a common denominator. So your LCD in this case, the number, the lowest number that they all go into would be 6. So you'll notice that 6 is already present, so we don't have to touch this one, but we're trying to get this 2 now to be a 6. So we're going to multiply it by 3. What you do to the bottom, you must do to the top. And same thing with this 3, it now needs to be multiplied by 2. We do the bottom, you do to the top. So now you're looking at 7 over 6 plus 3 times 2y minus 1 over 6 is equal to 2 times y plus 1 over 6. So now let's go ahead and combine your terms. So on one side, I'm just going to throw it all over the same denominator, 7 plus 6y minus 3. We talked about before not canceling out these values because, again, you are just essentially going backwards. So you did all that work for a reason. Do not undo it. 2y plus 2. So now how do we get rid of these 6's? Well, let's say we're just focusing on this 6, right? If it's being divided by everything and we want to get it out, because working with fractions can be difficult, right? So to undo that fraction, let's multiply it to the other side. So by multiplying it on this side, we get rid of it. And what you do to one side, we now have to multiply to the other side. And you'll notice on the other side, we have also cancel it out because there is a 6 on the other side. Now, the reason it does this is that now your numerator is equally balanced. You do not need your denominator any longer. So you're left with 7 plus 6y minus 3 is equal to 2y plus 2. Now let's go ahead and combine your like terms. We have 6y plus 4 is equal to 2y plus 2. And we're solving for y here, so getting y alone to one side. It's much smarter to bring this 2y over to the other side. And then subtracting 4. So you're left with 4y is equal to -2. So y is equal to -2/4, or again, -1/2. Now that would be considered a unique solution again, and we could figure out your y counterpart just by checking your solution, putting it back in, and seeing what your y value is, and at the same time, figuring out, is the solution actually true? Okay. So first up, next up, we have something with fractions. Now, for me, you are not allowed not fractions, decimals. For me, on your tests, on your quizzes, you are not allowed a calculator. So in this case, if you're really good at multiplying and adding and subtracting decimals, or even dividing decimals too, then great. You don't need this next part. I'm sure you got it. However, if you need, if you're not good with it, right? What we can do is get rid of the decimal altogether by multiplying something that's kind of neutral. You'll notice that all of these decimals are rounded out to 2 decimal places. Now, let's say only one of them wasn't. You're still going to multiply them all by the same exact number. And even better, if they are rounded out to 2, you're going to take however many rounded out spaces there are and multiply by that neutral number. So in our case, we're going to be multiplying these. If only this was, I don't know, a 15 and an 8 and a 25, right? This would be much, much nicer if we could just move your decimal place over. By moving it over to the right, we are actually multiplying each of these by 100. So we 100. So multiplying it by 100 just means that you get to move the decimal place to the right 2 spaces. The amount of zeros you have is the amount of zeros that you move. Again, even if this one was only 1 decimal place, you're still multiplying it by however many, however more you need, if that makes sense. So we have 25 times x minus 3 plus 8 is equal to 15x. So something a little bit more manageable now. They're just whole numbers, and we can take on the same exact application as we have done before. So combining your like terms, let's go ahead and bring your 25x to the other side. -67 is equal to -10x, and then go ahead and divide by that -10x. Now, dividing by 10 is going to now undo this process that we have done before. So going and instead of having just this as your final answer, we're going to take your decimal place that we moved over. And this 0 is telling us how many we need to move back. So just moving it back by, oh, and I'm so sorry, I left off a negative sign. There we go. So we're moving it over 6.7. So moving it over once. So that's how we can kind of kind of work our way around decimals.